Hello everyone, Mr. Skelton here. We are back at it for the last lesson in Unit 3, and today we are going to be solving nonlinear systems with and without a calculator. So I'm going to add the old with part there. We're going to do both. I'm going to show you how to use the technology, the graphing calculator, which is always nice, but I'm also going to show you how to do this by hand. Really what we're going to do, and if we look at the first slide, we're going to be solving a system by graphing. Now, just to give you some review, right? We've done systems with graphing before. We usually do them on the coordinate plane just like this, and we really have three situations, and I'm kind of adding more to your notes here, but just bear with me. We've had situations when we did linear, so this is non-linear, although if you look at this example and the one on your back, one of the equations is linear, the other is a quadratic. So you have a parabola and a straight line intersecting. But going back to our basic system days, we had three situations. Okay, situation one is where we had two lines and they would intersect, right? And wherever they intersect, that point right there, that would be our solution to the system. The second type of situation we had is where we had parallel lines. And if you had parallel lines when you graphed your systems, how many solutions did you have? You had no solution, right? And then the third situation when we did our systems is if you graphed a line and then you went ahead and graphed the second line, it's the same exact line, that gave us an infinite many solutions. So this was one solution, we had no solution, and we had infinitely many solutions. Those you could see in this lesson here, but for the most part what I'm going to show you today is where you're going to have one or two solutions based on the graph that you see. But I kind of wanted to show you this just to kind of recall some information on systems and graphing them. Alright, so let's jump right into this here. The first equation we have is a quadratic. So this is in standard form. Remember standard form. So we need to graph this. So this is good review for us for the test coming up. How do we graph an equation in standard form? Well, we got to find the vertex, right? So how do we find the vertex in standard form? We find the x value by going negative b over 2a. So here I have x equals, I have negative 4 over 2 times negative 1. So I get negative 4 over negative 2, which is positive 2. So I get a positive 2 for my x. So that means I have 2 comma something for my vertex, right? So how do I find my y value? I plug my 2 value in for x here. Now you got to be careful, right? We got to go 2 squared, which is 4, and then it's a negative out in front. So that's negative 4, and then 2 times 4 is 8, which makes 4, and then we're going to minus 3. So we should get 2, 1, right? Negative 4 and 8 is 4, 4 minus 3 is 1. So this is my vertex of my parabola, so 2 and 1. Now, looking at this equation, I see that my a value is negative, so I know that this is going to be an upside down parabola because my a value is negative. So how do I find my other points? Well, good review again is to make a t-chart. I always put the vertex kind of in the middle. You can put a box around it, and then you want to pick numbers to the right and to the left of that vertex, or the x-coordinate of the vertex. So the x-coordinate of the vertex is 2, so let's pick a number like 1 and 3. So if I plug in a 1, 1 squared is 1, negative out in front makes it negative 1, 4 times 1 is 4, minus 3, so I end up getting negative 1 and 4, which is 3, 3 minus 3 is 0, so at 1, 0, remember these are symmetric, so I know this is also going to be 0, and then I'll pick 0 and 4, which are 2 units to the left and 2 units to the right. So if I pick a 0 here, 0 squared, negative 0 is still 0. Plus 4 times 0 is 0, so 0 plus 0, I basically just get a negative 3 here. So at 0, negative 3, and then at 4, I know that's going to be symmetric as well. So at 4, 1, 2, 3, 4, at negative 3 as well. So there's your 5 points for your parabola, and again, just connect the dots, and there's your parabola. Good review for what we did in the first few lessons, Unit 3. Now the second equation here, I'll put it in blue here, is just a basic linear equation, right? Y equals mx plus b. So we have our y-intercept at positive 1, so that's where I'm going to start. This is going to be a straight line. My slope is negative 1, so in other words, it's down 1 and over 1. So I'm going to go down 1 and over 1, down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. And you can put as many of these as you want to on here, but essentially this is what you get, okay? And then we're just going to connect those dots. And what are we looking for? What's the whole point? Well, just like up here when I was explaining to you earlier, we're looking for where lines intersect. Where lines intersect, that's our solution. So where does our parabola and line meet? They meet in two spots. The first one being 1, 0. And the second one being, let's see, 1, 2, 3, 4. 1, 2, 3, 4, negative 3. So it says solve the following system by hand. These are our solutions right here. Those are our solutions. And you can easily check those. Plug 1 in for x and y in, or 0 in for y. So negative 1 plus 1 is 0. And you could plug 4 in here and negative 3, and you would get those to work. Okay? And again, you could come up with a situation where you have, there's my xy coordinate plane. You could graph a parabola, and the parabola looks like this, and then the second one could be a linear equation that looks like this. How many solutions would you have? You'd have no solutions because these two graphs do not intersect. So that would be an example of no solutions, which you may see down the road, just to keep in mind. All right. The next thing I want to do is take this, actually, you know what? Let's just flip it over. And I'm going to show you how to do this problem with your calculator. So I can go back and show you how to do calculator for the first one if you'd like, but I'm just going to go ahead and show you with this one here. So let's take our graphing calculator out and try to get the glare. Usually it's better if I put it on this side. There's less glare. Try to get the whole calculator in view for you here. Okay, maybe zoom out just a scotch. Perfect. Okay, so turn our calculator on. If you hit your y equals button, if you have something stored in there, I'd make sure I clear it. For me, always when I start something new, I'm always resetting. So second mem, go hit number 7, which is reset. Hit enter on all. Click down arrow for reset, and reset your calculator. Okay, so we're going to type both of these in. We hit our y equals x squared minus 8x plus 12. And I push the down arrow key, and then 4x minus 15. Okay? Hit graph. And you should see your parabola, and then you see the linear equation running through it. Now, with some of these, you're going to have to adjust your window, right? You know that this is obviously intersecting right there, and we're going to find that point or calculate that point, but if you look at the top of your screen, it looks like those are going to intersect somewhere, but we're going to have to adjust our window. So when I look at this, remember, I'll write on my paper here, x and y. Those are your x and y axes on your calculator. When you hit window, if you want to go further up, you want to adjust your y max. Y max is the positive values on the y axis. Down here, if you wanted to look below, that's your y min. If you want to go more to the right, that's your x max. If you wanted to look more to your left, that's your x min. So when you hit this window, you see those things show up. So if you go back to graph, okay, I need to see above my calculator, so I need to increase my y max a little bit. So I'm going to go to window. I'm going to go my y max as, I'll go 30. And sometimes you can do the scale, so I'm going to go every 4. So what that means is every dot on my calculator will be by 4. So if I hit graph, I'll just see if this works. I may have to adjust it even some more. Oh, I'm pretty good. I'm gonna increase my x max. I'm gonna move it to the right just a touch. So I'm gonna go down to x max, and I'm gonna make that a 15. Let's see if that is helpful. That's pretty good right there. Okay. And if you wanted to kind of zoom in without hitting the zoom button, you could make your scale, your x scale, I could make that 4 as well. Let's see if that makes it even clearer. That's pretty much, I mean, it kind of zooms it in because, again, every dot now is 4, but that kind of works. So let's get to the calculating part. It's very, very similar to how we've been using our graphing calculator to find zeros. If you remember how to find zeros, we're going to hit our second button and trace, which is the calculate. So now instead of calculating a 0, which we've done in the past, we want to calculate an intersection point, which is number 5. So hit enter. and it's going to say first curve. So you want to make sure your cursor, that little spider thing, is on one of the two. Right now mine, you can see, is right on the parabola. I'm just going to hit enter anywhere on there, does not matter, but close to the intersection point. You don't want it way up here. You want it kind of close to the intersection point, but you got to be able to see which line it's on. So yes. Second curve, again, just make sure it's on that line, which you can kind of see it. There it is showing up. So I'm going to come back down here where it's close. Just hit enter anywhere, enter. Say guess, hit enter again. And it says 3, -3. So 3, -3 is one of the intersection points, thus one of the answers. And again, if you just plug that in here, 4 times 3 is 12. 12 minus 15 is -3 for y. Boom, that checks out. You can plug it in here, you get the same thing. But now we also have to calculate this intersection point because this line intersects the parabola twice. So we just do the same thing over again. Second, trace, go down to intersect again, hit enter. Move your cursor. I'm back on the parabola, okay? I'm just going to hold it down or keep hitting it until I get close to that point. My spider, I call it a little spider, little cursor there is close. Hit enter. It's going to say second curve. It's usually right there. Good. Hit enter again. Hit enter again. And you get 9 and 21. And if you take 9 times 4, which is 36, minus 15, you get 21. All right? And you can plug it into the other one. It works as well. So that is how you can solve this system with your graphing calculator. Very similar to how you found the zeros. Okay? And that's it. That's our lesson for today. Pretty quick and hopefully painless for you. But if you have questions, if there's anything I can clear up for you, I'd be happy to do that. All right? Okay.